Hi, Tommy. In order to test the function block, I created a SolidWorks model that I've imported. Actually, I've imported 3 instances of it and put one left, right, and in front of the robot. And if I zoom in a bit here, you can see that there's some pins here representing positions to correct from. The center pin there is actually red. I don't think you can see it very clearly, and that represents the tube. So on the HMI that I've connected to this PLC here, I have a HMI. So I registered the positions in each location, and then we can move to the particular position. These figures here represent the actual displacement from the center red tube for the 4 pins. So we have a plus minus figure, minus minus, plus minus, and plus plus. So if I switch back to the robot here, and if I move around, I can move to the 4 positions, the 4 offsets, and the idea then being that the function block will give us the figures to correct to the center pin, this red pin here. So for the first location, which is this one here, the figure is minus 25 plus 10. So I'll key that into these 2 figures, and this will be 45 because our cameras are 45 degrees off the horizontal. So on the HMI, I will key in 25 minus for the X and 10 plus for the Y, and the adjustment is 45 degrees. Then I register that, the output from the function block I'll register as a position and then move to that position. So it shows it moving to the center. The second one, I'll move to the second location, flick back to the HMI. Here the figure is minus 12, minus 5. So again, I'll change that on the HMI, 12.5 minus and 5 minus, enter. Register the output of the function block at that position and then move to that position. And again, it moves to the center. Move to the third one. Flick back to show that that's 45 millimeters on the X and minus 2.5 on the Y. So if I put that into the HMI, 45 and minus 2.5 minus, enter. Register that from the function block and then move, where are we? Sorry, I'm hitting the wrong button. Move to the corrected position. Then finally, we'll move to the last pin, and that is X, it's plus 32, and Y, it is 4.5. Output from the function block, register position, and move to the tube. So I've done that for the 3 locations there. I've done that for the 3 locations. See, the 2 cameras that I've drawn in, this here is the X, and this one here is the Y, is giving us the Y displacement. A quick look at the function block. The function block is also allowing us, the top here, the function block is also allowing us to put in the tool, so the 45 degree displacement, the FH adjustment, And inverted, is the actual robot inverted? So it wasn't in the example so far. If I change that to true, I also have a section here, and I have it set to 20, and I have the robot actual position, which includes the joint coordinates as well. So the idea of this 20 here is we can segregate out the positions that the robot is facing. So the 20% here, it means you can actually reduce that down to 0 if you wish. And then for an inverted robot, so that's 0, 1 and 2. For an inverted robot, it's 3, 4, 5. So your initial robot setup would be 3. So if I flick back to ACE and load a different file, I can do this inverted example. So I'll load that up, and this time we still have the three models, the 3 instances of my SolidWorks drawing. I just zoom out there. So, but this time the robot is inverted. Now if we're in section 3, going back to our drawing here, so for over this side, we should move into this direction here. So I just configure. So now we're over on the right hand side. Just turn that around. And shift it over to the left maybe, and then zoom in. So now we're at the first position. We can go to the second position again, third position, and fourth position. Back to the first, and if you remember, our figure was minus on the X, minus 25 and 10, and our angle again is 45. The function block now will give us the corrected absolute position, so we load that in and then move to the corrected position, which again is the red center tube. We move to the second position, that is 12.5 minus and minus 5. Load that again as a position and then move to it, so it corrects in the right orientation. And then the third one is 45, enter, and minus 2.5. Minus 2.5, enter, load the value from the function block and correct to the tube. And finally, we have our plus plus, which is 32, and for y it is 4.5. Load the results to the function block and move to the corrected value. We've tested this, I've tested this for the three locations here, and it works fine. So that the idea then is that the only thing you have to do when you use different robots is to decide to put this to true or false if it's inverted, and then decide on your window in order to tell the function block when to use which orientation. The outputs then are the new coordinates, some details about the actual corrected value the function block comes up with, and there are some errors and error codes. So that's it. Any questions, just let me know, and I'll send on the library file for this function block, and a small manual here that I've done out, just showing the inputs, what they are, what data types, the plus or minus figure. We can go plus or minus 90 degrees, so we have it set at 45, and then a description of the sections and some error details and so on. Okay, Tommy, thanks.